start with sort of the last few bits to show off on the water side of things. So this is actually dealing with more the flood management side of things opposed to sort of the water saving inside the house. So here we are, as you can see, outside. So what we've got here is there's a series of sort of planters, and what these are going to be doing is they're going to be taking the rainwater from the roof of the house. So normally it would just go into your drain, into the main sort of sewer system, flood the city, or into a river and into the sea. So not always so helpful. And we need to really start changing the way we approach designing these solutions. So here we have the first planter. Now what happens is the rainwater goes in, and normally that would just fill the planter with the plants, but what we've got here is a really interesting bit of tech which is called Hydrorock. So what Hydrorock does is it can be used in two ways. One is to attenuate water, which we'll come into in a moment, but also it can be used like irrigation. So basically what that means is that this system here, it will have the plants growing in a normal sort of depth of soil, but then underneath that you can have the Hydrorock, which can soak up all that water that's coming from the downpipe. But then what plants can do is they can actually suck water out of that using capillary action. So it can work like an irrigation system which is incredibly resilient, and it doesn't rely on sort of drip irrigation or those other irrigations which are then subject to evaporation from the soil as it gets hot, or won't permeate if the soil's already very hard. It can just go straight into the system. Now the idea is that that will then flow, if it overflows, it will flow into this next planter, so that it uses exactly the same system. Now the paving here is also permeable under my feet, and what that means is, like before, it's going to soak through into the ground, but also we can use Hydrorock beneath that to add additional capacity. So normally on a big, significant project, you'd have lots of big tanks in the ground to attenuate the water. But that's a really big sort of engineering problem. You've got to dig a great big hole, you've got to tank it, you've got to put the crates in, you then got to make sure it doesn't collapse when stuff drives over it, all of that kind of thing. Whereas here, you can essentially have your normal permeable paving, then underneath have the Hydrorock, which will then mean the water can soak straight through the paving, straight through into the Hydrorock, and you can have your attenuation spread out across the site. It's very, very easy to install. You don't have those big sort of geotechnical problems, so that's great. But what we also have here is we add an extra level of resilience to again just showcase it really here and explain how the system can work. And what we've got is there's a series of grills which run along adjacent to the property. So that's there just in case the people that move in don't look after the paving, which a lot of people probably wouldn't. Again, it's just a show project to demonstrate this stuff in one place. So the idea of a lot of this is to demonstrate bigger concepts, the bigger picture on a small scale of how it can work. So these grills will catch any surface water that's running off if it gets blocked up or there's a really serious flood, channel it into another series of Hydrorocks, ferry it around the property into this soak away in the rear garden. So that's how this sort of core bit works here. And the other thing to add on this raised planter is that actually the idea is potentially, if people want to, and once they move in, to grow vegetables and things in here. So again, it's to sort of demonstrate actually additional resilience. So actually you can have some food growing, but that food growing, you won't have to come and water it every day, and you won't have to worry so much about it drying out in the summer, because the Hydrorocks is there and it's going to allow the plants to suck the water out of it. So it's also sort of demonstrating more sustainable food production. And this system has been found to be really effective for things like date palms and avocados in other countries, where it's reduced water consumption by 60% for avocados, which is crazy. It's a massive water demanding plant. But also it doesn't like a lot of water available all the time or too much water. So actually it's been found to increase productivity as well, because they can suck it out using capillary action. It means that actually they take the water as and when they need it, which also reduces the amount of water you're putting on, reduces stress on the plant, and that has led to about a 25% yield increase in avocado production. So massive water saving, yield increase, and also you can put water soluble fertilisers into that, so the plants are sucking it out as and when they need it to. You're not just covering everything in fertiliser and then contaminating the rivers and the soils as much. So very, very effective, very interesting new technology. So here we've got the attenuation system. So my foot here is on what is your typical highway drain. So these run every so many metres along a typical road, and they're designed to take all of the runoff from that road. And again, normally that just goes into the combined sewer system. So our sewer system in the UK is typically a combined one, which means that it's sewage and rainwater. So it's not particularly helpful, and this is partly why we see really big sort of pollution incidents where sewage works are overflowing into the rivers and contaminating them really heavily. I'm just going to stand on it now out of the road. So that's where the water comes in. So we basically disconnected that, and so it's going to flow directly into this system. Now this is really interesting. So normally, as I said, you have them every few metres. But what we've done here is we've managed to take all the water for a 100-year flood event and attenuate all of it in this swale. Now normally a swale is sort of up to sort of 500 mil deep at most, and then you normally get water sort of sat in it, which can cause a lot of problems for people. They worry about sort of safety, or kids falling in it, or if it fills up with water, you know, there's another risk there, people tripping, all that kind of stuff. That's not really a problem, but people sort of just naturally worry about. So this is actually, as you can see, not very deep at all. It's almost level. There's a slight divot in the middle for sort of rainwater and things. But that's because this system here, where it comes in, feeds directly into the hydrorocks, which sit beneath it and are really quite deep. So what it means is those rocks can soak up that water, and there's a pipe running in which connects into this very big network of them under the ground. Now the hydrorocks are really interesting for another reason. So we've already talked about how they can be used for irrigation and water resilience in terms of drought and things, but here what they can do is they can also filter out particulates. Now that's not such a problem on the other one because the water's just running straight in from the gully, well, from the gutter, sorry. But here it's coming in from the gully, so it's going to have like hydrocarbons and heavy metals and things potentially in it. So they're going to help filter those large particulates out. Now you may wonder how it doesn't filter out fertiliser, but it filters out the particulates. So the fertiliser is sort of dissolved in the water, if you will, so it can flow through. Now the last bit to sort of mention here is the planting. So the planting has been chosen to be really climate resilient, and unlike a normal swale where you'd have things that are very sort of tolerant of sort of, you know, periodically wet areas or from patches that might have standing water. Just wait for that van to pass. This is all actually quite drought tolerant, and that's because it's not really going to have water sitting in it or going into the topsoil in the same way a normal swale would do. The water's just channeled straight into the hydrorocks beneath to attenuate it all, and because of the depth of the hydrorock, it's not really possible for the plants to suck the water out of it because it's just too deep, unlike the other system we have over there. So it's using a product in two different ways for sort of two different solutions. The other thing to note is that having something like this, where you can actually put more of a diverse range of plants in, compared to what you might be able to see in the background where it's just grass, is obviously there's a much more significant sort of biodiversity uplift as well, depending on the species you can put in. So here they've got to be quite resilient because it's a very small area, it's part of a show home, it's a slightly different scenario, but in other areas you might be able to have a much more wider variety of plants or whatever it is to try and improve biodiversity too. So it's all about thinking, you know, how can we integrate solutions to deliver, you know, as many benefits as sort of possible. So it's not just about water, it's also about biodiversity and all those things too.